Okay, so that's... Oh yeah, I can see my face. Alright, check. Can you hear me? Okay, so that's... Oh yeah, I can see my face. Alright, check. Can you hear me? Okay, so that's... Oh yeah, I can see my face. Alright, check. Can you hear me? Okay, so that's... Alright, okay. Please check the video resolution. And just trying to set up the stream settings. So this looks alright. Okay. Down a bit. Yeah. So there. So I'm streaming at 480p, which YouTube doesn't like, but I think. Alright, so let's see, what is the URL for the stream? Okay, so thank you Andrew, that's good. Let's see. Now let's see if we can sort of minimize me and maximize Din, right? So does that work? That works beautifully here, but does this work? I'm hoping that Andrew would tell me something. So bigger, I can make myself smaller. Wonderful. Wonderful, I've got into a corner. Great. So let's bring me nice and big, because I'm going to give a speech initially. So that's sorted. Okay, so now I'm going to give the URL to the guys in Poland, and hopefully when they want to dial me in, they can connect to the URL and just project me and audio everything out. how am I going to talk to them? That's going to be an issue. Somebody has to sit in the chat room from Poland. Who do I know? Well, okay, so I'm going to just tell the Polish guys that I'm basically on air right now. So, okay, so this is great. So I'm now get the shareable link. Yeah, that's it. I get the shareable link for the stream, and now I have to just email it to the professor who runs the audio department in the music academy in Krakow. So I'm gonna ready and live, sir, at this URL. I'm gonna pasted the URL. Something. Let me know if you can see me or something, and I'm gonna just send that email across to Professor Marek Koloniewski. So the first time I met him was in 2014, and it was just a wonderful time. You know, a wonderful time of my life, I guess. Relative to now, everything is wonderful, right? But it was quite a nice time. Found new friends, and yeah. So I've sent the link to him. All right, that's great. Now I'm gonna post on Facebook to let my few followers know that I'm live and they can even see me. I don't know how many people want to see me, but very few people are interested in Dan, and I'm sure less are interested in my face. Yeah, and look at me, and it's a massive beard and everything. So yeah, I need to shave. I couldn't get the razor blades, you know, like delivered, locked down. Get the razor blades delivered, so couldn't shave. All my razor blades just run out. So Gillette YouTube stream. All right, so I'm going to insert my YouTube stream URL here. So let's see. From the computer is a bit loud. Okay, so okay, that can be sorted out. Right. What is loud? Is the microphone loud, or is it the din itself is loud? Din can be irritating, you know. Like sometimes it can be irritating. Where is din? I don't see the software anymore. That should be slightly. So let me move this to a different workspace. So workspace 1 is going to be DIN, workspace 2 is going to be the OBS, and workspace 3 is going to be the stream. So all good. Oh man, it's not enough receiving enough video. Experience buffering. Okay. Let's see. minute. Oh my god, that's like... Okay, so... Like how much was I? Wait. How much was I streaming already? Use stream bitrate of system status. It's poor. Well, if it doesn't work, we tried. So wait. Go there. So this one is 2,500. What's that? 2,500. Start settings and back to output and video. Gonna use ultra fast is where it's at. So okay. So yeah, I try my best. So hopefully you guys can hear something. If not, then maybe do another stream another day or something. So let's see. So I'm waiting for the professor to tell me I can go. I'm gonna literally talk into the unknown, the void basically, because I can't see anyone from there. Just I'll ask him to give me a yes, I can go, that kind of thing. Standing by for command. Chat. I can't see anyone from there, so I'll be doing this. Okay, so I've sent the email to him. All good, go for it. Excellent. So that is good. Alright, so we're gonna... Alright, so the sound test is working, so I'm gonna close that down. So that's a relief. The drones are not, you need, with din you always need to pay attention to enjoy din, right? So if you don't, then it's a bit... Alright, so I'm waiting for a go, no go, and if I get a go, then I'm gonna go into the corner, and I think I've got a go. We see and hear you go. Oh my god, oh my god. Wait, okay, so hello, so this is Jag. I'm talking to you today from India, in Chennai in India, and we are suffering like you once again got 4 years of your same president. Sorry. We are suffering in a different way, which is the corona epidemic. All right, so but this is not about that. All right, so this is about what I was in Poland. I was invited to talk about my work in Poland in 2014 by the great professor who's running the concert today, who's the man in Poland, right? So he was kind enough to invite me, and I was able to give a lecture demonstration of my work until then in Din is Noise, which is my software. I've been working on it for the last 14 years. Sometimes when people ask me, I tell them that I've been working on it since the 2 world wars, right? So anyway, yeah, so and my I'd just been working on it for many years, and the the main thing in DIN is that why did I start working on it was because when I look at, I'm from a computer animation and graphics background, and when I look at sound software, I wanted to get into computer sound, and when I looked at sound software, it was all very, text-based or very, very kind of visually quite primitive, in the sense that the sound was all right, but visually it was primitive in the sense. And then I thought that I was interested in geometry, and I wanted to see geometry as sound. And sound as geometry, which kind of came up later, but initially the aim was to kind of sonorize geometry, right? But in a very intimate way, not just in a superficial way. So that's one. The second part was to not be restricted by the piano, to keep it really simple, right? You could say Western music in general itself is very much piano, and all the composers, your famous ones like Mozart or Beethoven, you know them all, right? So they're all sitting on the piano, right? Bach, everyone sitting on the piano. So I with the computer, you can dial in any pitch and volume. You know this, right? So and the piano is 8 octaves and 88 notes, whatever, right? So analog synthesis knew that, okay, you could synthesize any sound, right? But one of the problems is that how do you structure it? How do you make it manageable? How do you make it interesting, right? So that's one of the problems that analog synthesis face. That's why you see in analog synthesis there's thousands of knobs, and people turn in this and that and everything, and it gets quite complicated, right? And the third thing was that, so as I said, the second thing was I didn't want to be limited by the piano, right? So the third thing was I wanted to really explore the potential of the computer, right? And software in particular, right? Right now we live in an age of software, but sadly software is like hated. Everybody hates software, right? Why? Because they, Facebook and, they basically got your, so it's very surveillance oriented and all that. So, I didn't start, doing software in that climate. Like I genuinely love software. I really still love software. Like every day I think about software, right? And so for me, the idea was that I want to really explore the medium of software by writing software and by making visuals and make sounds, make geometry to sound, this sort of thing. So that is my motivation. So these are the three main things, right? So to really ultimately explore the medium of software, because software is a very young field, and we've always been solution providers, right, to everyone, like, to every field, including musicians, right? For me, I want to see software as its own medium, right? And, I'm sure other people, are talking about that as well, but in music, like, to play the laptop as an instrument, people think that, they want to bring MIDI in, they want to bring weird controllers, light, and, kind of like, make Alexa create sound, things like that. But I'm really not too interested in that. I'm really interested in the other thing. What I was trying to come to is virtual structures, to create virtual structures and then have virtual processes, right? Virtual, all of it is software. All of the inputs are generated in the software. And so the virtual structures, virtual processes, you could call them virtual engines, right? And to make sound with that and to see where we can go with it. And really, really explore the limits. I know people say, I want to push the limit and stuff, but really edge cases in computational sound, right? So we want to see what are the limits of the computer itself, right? So we want to explore that, and we want to explore. It's not about composing, or it's not about making pieces of music and stuff like that. DIN is not like that. So DIN is very much an exploratory tool. You could say it's like a telescope, or a microscope or something, or at least a magnifying glass, right, to the sound space. So with that, I'll just rush to the corner, right, and bring DIN out. Hopefully it'll make sound, and hopefully I'll show you some concepts that I've been working on these many years, and hopefully it'll sound right. Okay, so I need to switch the window, so I need to go the other way, and hopefully I'll still be alive here, I mean on the corner. Yeah, so this is called the Microtonal Keyboard, and it's kind of like it's kind of starts off with the piano, but it really, you see that you have C, D flat, D, and so on. But every pixel is a pitch, right? You can see my cursor, right? This is C, right? When I place my cursor right there, it's C. But when I move it along, it basically moves very smoothly to other pitches. So I'll just demonstrate to you by just having a drone. Like a drone is, you know, because you're all in the music academy, so you know, drone is just a pitch and the volume, right? So can you hear me? Let me bring the master volume up. Right, that's good enough. So this sort of thing, so I can have many drones, not just on any particular pitch, you see. So you could like, so these are all pitches, right? So like I could show you, and I could scale it, for example. You see the pitches there. So all of these are pitches, and the percentage is the volume, right? So I'm going to delete that, right? So the horizontal is pitch and the vertical is volume. Okay, so I'm going to just demonstrate to you something, and you can scroll it. It's like very much like a game, you know, like you can scroll up and down, left and right as you play, and you can use the mouse like a bow. So in a way, it's like a theremin. So I could do something like that's kind of like a, yeah, that's kind of like a theremin, but you can be very precise with how, because the mouse is a very precise input device. People underestimate the mouse, but mouse has been around since the 1960s, right? So you can be quite precise. But let me go back to the drones again. I'll turn the delay off, right? So I'll go turn the voice off as well. And let me go to this thing where I said geometry to sound, right? So I'm going to call this as the create drone pendulum. So it's this, I'm going to click that, and I'm going to create this drone pendulum. Hopefully this is all going to work. So I'm going to, you see that? So what's happening is that you have these bunch of drones. Yeah, this is nice, isn't it? So this is geometry to sound. This is what I was talking about. So every drone is actually making a pitch and a volume, yeah, which is changing constantly, right? It's constantly changing. Like I can freeze it, for example. So I can freeze it, raise the master volume. Maybe move them around. Much better. I can go to the drone pendulum editor. There's many editors in the software. Let me reduce the master. So this is based on very all the drones are slightly in different phase, so they kind of sometimes sync and sometimes move away, right? So their volume changes, their volume unifies, then diverges and converges, right? So that's basically, you could say, as I said, this is a virtual process, a virtual engine, if you like, you know. So now let's go to the drone pendulum editor, and I can edit how the amplitude behaves. For example, this is the amplitude curve, so I can do something like this. So I could do like, or I could maybe just bring this guy there and kind of take him there, right? So there, yeah, it kind of looks complicated, and I'm fumbling because I'm a little bit nervous, but anyway, so I'm gonna kind of, yeah, so now do you see that? So this, what's happening is that the amplitude is not moving in these two endpoints, but it's moving like this in the other, you know, the other amplitudes are moving like that. So you have something like this. So I could overlay the instrument and increase the depth, right? So it's a bit like this. Now I could scale it if you want. Do geometric operations. Like I said, move, scale, and rotate are the three geometric operations, right, that you have in 3D, 2D basically. So I can scale it. So you see that? Something like that. Maybe I can go to the waveform editor and bring in some harmonics if you want. Bring the second harmonic, third harmonic. You can paint the harmonics. Yeah, now it's better, right? So you can sort of, and I can maybe, you know, increase the rate, right? You see? So we reversed it. You see, with the, you see all the geometric operations, right, because they are all happening in the geometric space, right, and the sound is the result of geometric operations. So the geometric operations are always valid, right? So I can flip, I can scale in negative and it would flip, right? So it would flip, it flips, you see. And you can do musical operations, like you can snap these guys to notes. If you don't like all the in-between notes, go back to the piano, you know, like that, for example, right? Just do FM depth. FM depth is basically along the horizontal axis. So unsnap, yeah. So increase the BPM. Yeah, you've been familiar with that. This is your typical computer sound, right? Oh, the bees. Oh, look at the patterns there. Interesting. Right, so you can do something like this. So I just want to show you something else which is much more interesting. Professor, please give me some more time. I can't see you, I can't hear you. I'm just talking to the void, so give me some more time. I want to show you something really which right, so let's see. So my depth, so I'm gonna bring that down to 0, right? So I'm gonna turn the overlay off. It's all 0. Go back to the main screen. So what I want is just use the same drone pendulum. Now they're not gonna change in volume, so they're just gonna be flat like this. Okay, so I'm gonna like that. Okay, so I'm gonna take that and move to the left. Right? Go somewhere nice and low, like that. Maybe down a bit. Right. Now I'm gonna do tools connect. Right. So what has happened is it has actually created a relationship among these guys, geometric relationship, right? So now I'm gonna just maybe go in there and go to the visual. Maybe I'm gonna increase the handle size a bit, right? So they all have some handles, so I'm gonna just do that a little bit randomly like that there, and then maybe the depth there, just make it like that. These are just cosmetics, yeah, but they can be quite useful. As I said, you know, the visualization is very useful in sound as well. So, and then I'm gonna do that, and I'm gonna do that, kind of make it like this, maybe like a hammerhead shark, maybe, yeah, like a hammerhead shark. That's like a hammerhead, okay. So anyway, so now this guy is selected. Now if I can select and I can move that. Now see what happens. Right. Yeah, something like that, right? So you can make it move really fast if you want. So increase the connection stiffness and then you see what I'm talking about? Exploring the sound space really through visual process, visual engines, geometric structure, visual structures. Right? So I'm gonna have it like this. Now I'm gonna take a bunch of these guys, right? And just disconnect that, right? And then actually I'm gonna connect it, right? So now I'm gonna maybe move this guy up. I can even pull him from the back, right? And then get this guy, connect, maybe increase his width, maybe make the hammerhead. Because I'm Indian, I like to go on this note, right? Dissonance. But let's give something nice and lovely and holy. Now let's get this guy, our original worm. Nice and lovely, and you got the C major chord, I think. Yeah, C major. Not anymore. So all of this is between the notes. Yeah, between the notes. Let's kind of make the connection stiffness really low, so we get something like this. Let's now so I was trying for the D minor, I think. It's like a party piece for me. Now this is D minor, right? But you see that we went through the whole space, or we didn't really even care whether there was a space or not. We just move freely through the sound space, right? Just like we move freely through space. So that's the idea, basically. Alright, and then now I just want to show you one last bit. Let me put it back in D minor. And then I can stop. I can show you just one more thing. And then, oh, that's nicer. Yeah, I want to be there, alright? So we're going to be there. Now let's go back to the waveform. And I talked about geometry, right? So paint the harmonics. So only the lower harmonics. Ugly. Let's turn this off. We're painting the harmonics, and this is the geometry. If you say make shape form, you get this geometry because there is a cos function on the x-axis, sine function on the y-axis. But if you take this off, you get your sine function just on the y-axis, which is the audio sample. So you get this, right? So this is your typical sine wave, a mix of sine harmonics. So you could kind of, you could make these operations. Just we are sliding the harmonics, you see. It's like bit shifting in computing, right? This is what I'm saying about computation. I want to understand computation also, like, you know. This is what is called bit shifting, right? Inspired by bit shifting. It's not exactly bit shifting that's happening there, but and you could have other user interface things, like you could expand this or things like that, but I won't show you that. Maybe let's go very quickly up there. Yeah, now it's back to kind of and then I want to show you this circular thing, right? Before that, maybe just set the start angle to 90 and maybe end angle to, so this is your hexagon, right? Probably very low. Yeah. So I'm gonna take a few more minutes, just 5 minutes, maybe 10 minutes. Yeah, and I'm gonna stop. All right. So this is a hexagon that's transformed into a waveform, and all of the drones are actually using that waveform. So there is only one oscillator for all of the drones, all right, which is kind of plenty, I guess, for now. Yeah, but in software you can always keep on changing, right? So you know that. So the start angle and end angle, the difference difference is 360 degrees, so it goes around, so you can have partial angles. So what the DJ is doing. So back to the single harmonic, right? Now you know what the DJ is doing when they're scratching and doing things, you know. This is nice. This is just all romantic. COVID-19. Romance. COVID-19. When are you gonna let me out? COVID-19. COVID-19. When are you? When are you gonna let me out? COVID-19. So you could do something like that, right? That's not bad. Like I could record that and maybe put it on Bandcamp or something. COVID-19. When are you gonna let me out? COVID-19. They're gonna lock us down. They're gonna lock us down. Squeeze our soul. COVID-19. So yeah, COVID-19 is just bothering me. Like when are they gonna? I mean, is it real? I mean, how can they have elections in Poland when there's COVID-19? Anyway, so let me go very quickly to the spiral waveform. I want to show you this. Alright, so COVID-19. Let me out. Let me out. Right, so that's like, so I'm gonna finish 2 minutes and I'm gonna bring that down, right? COVID-19. And this custom radius is really very special. I mean, I'm enjoying doing this, like because I'm learning maths in a better way, in a really intimate way, which is away from the textbook in a way, like. So now this is custom radius. So this is radius as the spiral turns. All right. So. And I can automate this as well. So let me show you that. COVID-19. COVID-19. Where did you start? COVID-19. Are you really from China? COVID-19. Are you from a virus lab? COVID-19. COVID-19. Oh, okay. Let me. let me. Yeah. So we are automating this, right? COVID-19. 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 So you see that? So it's all, you see the harmonics there? You know, because I'm streaming, it's kind of glitching a bit, but yeah, COVID-19, COVID-19. Thank you for watching, and hope you survived the pandemic. And if you're out there in the auditorium, thank you for listening. And yeah, just don't mind it if the song wasn't good. So see you on the next one. Thank you, Professor. Thank you, Poland, and thank you all for watching and supporting my work over the years with your goodwill, right? I hope you give me some more dollars, because anyway, nah. Okay, din is noise. What I showed you tonight was din is noise. Din is noise. Enter it into Google, din is noise, and the first link is my link. I'm that good. So I'll see you all on the next one. Good night. So I'm gonna come back into the big screen. So do you like my beard? Professor, do you like my beard? What do you think? It's good? Should I keep it or no? Do you like my art? So I'm doing this. Yeah, my mom doesn't like it. Do you like it? Yeah, alright then. Good night. Bye bye. Take care and stay indoors, and use a mask. Wash your hands. Alright. And you don't have to fist bump, or you know, you can do this. That's what the Indians have been doing for many years. I don't do it, but well,